All right, we're gonna be doing 1973 AB3/BC1. So this was an old free response question that was on both the AB and BC exams. That's still actually pretty common. There's usually like 3 per year that are on both tests, I guess. And so let's see. So given the curve, x plus xy plus 2y squared equals 6. All right, what are we gonna do? Find an expression for the slope of the curve at any point xy on the curve. All right, so for A, we're going to be doing d dx of x plus xy plus 2y squared plus d dx of 6. So sometimes I skip this step, but I don't think that's really a good idea. I just kind of do it. Potential pitfalls here. This is going to be a product rule. And then here, this is going to require the chain rule. Other than that, I think this is going to be, I think this will go well. So 1 is the derivative of x. And then product rule. So first derivative of the second plus second derivative of the first plus chain rule. The derivative of 2y squared is 4y times dy dx. So 4y dy dx. The biggest mistake that I see people make is that the derivative of a constant should be 0, and people just forget to do that. So this. Now we want to solve for dy dx, so I'm going to say dy dx is, I'm going to take everything that doesn't have a dy dx, so this and this, I'm moving over here. So it's going to become negative y minus 1. And then everything that's coefficient of dy dx, x plus 4y, I'm going to divide by. So x plus 4y. And that's it. I'm going to leave this as my answer. We could take a negative out and like put it in the front and negative quantity y plus 1 over x plus 4y, but like what's the difference, you know? All right, write an equation for the line tangent to the curve at 2, 1. So we're already told the point 2, 1 is on the curve, so we don't need to confirm that. What we do need to do is we need to find the slope. So dy dx at 2, 1 is going to be negative 1 minus 1 over 2 plus 4. So negative 2 over 6, negative 1/3. So the tangent line is going to be y minus 1 equals negative 1/3 x minus 2. So this is like a really old question, but I might check it on the calculator at the end anyway, just to like, because you can, you know. There's like a little gnat flying around in here. Like I know that you can't see it, but it's like it keeps landing on the iPad screen. And I really want to like stop it, but whatever. All right, let's see. Find the coordinates of all other points on this curve with slope equal to the slope at 2, 1. All right, so the slope has to be equal to the slope at 2, 1, which means that the slope needs to be negative 1/3. So they used to do this all the time. They don't do it as much anymore, where like your answer to C is 100% dependent upon your answer to B. So if you got B wrong, actually if you got A wrong, you got B wrong. And then if you got B wrong, you're gonna get C wrong. They don't really do that so much anymore because I think just more people take the test and it's harder to get a sense if you really know the calculus, if like you're basing everything on like wrong answers and it's just kind of like going terribly for you. So not so much dependence between parts anymore. Still a valid question though. So I think the slope at 2, 1 was equal to negative 1/3. And I think that the slope in general, so we're looking for, we need dy dx to equal negative 1/3. I think dy dx was negative y minus 1 over x plus 4y. And that has to equal negative 1/3. Okay, so my plan here is I'm going to find a relationship between x and y that makes this true. Then I'm going to take the relationship between x and y. I'm going to go up here to the original and somehow substitute it in and see if I can solve. And I hope that works. So let's see. I'm going to kill the negative sign right away and bring the 3 across. And then x plus 4y. I think that's right. 3y plus 3 equals x plus 4y. So that means that y is equal to So I'm bringing this over to get y. Bring this, y is equal to 3 minus x, or negative x plus 3. Y equals negative x plus 3. Okay, so what is this? This is our relationship between x and y. Relationship between x and y when the slope is negative 1/3. So when the slope is negative 1/3, y will be equal to negative x plus 3. Is that true for the point we were given? So the point we were given is 2, 1. So if I do negative 2 plus 3, I get 1. So it works for that point. It's going to work for any point where the slope is negative 1/3. So now I will take this relationship and I will plug it into x plus, let me just write this down so I can bring it with me. xy plus 2y squared equals 6. I'm going to bring that down so that we can sub into it. Okay, so here, and then I'm going to replace y with negative x plus 3. So x plus x times negative x plus 3 plus 2 negative x plus 3 squared equals 6. So in theory, if I solve this quadratic, the solutions should be the additional points on the curve where the slope is negative 1/3. Let's see if that works. X minus x squared plus 3x. Okay, so plus 2 times x squared minus 6x plus 9 equals 6. There's no way to know with the older questions if like are you overdoing the algebra? Like who knows? 2x squared minus x squared is x squared. Minus 12x plus 3x is minus 9x. What else? Oh, there's another x, so minus 8x. And then I should check that again. Yeah, minus 12x plus 4x is minus 8x. And then 18, but then minus 6, so plus 12, 0, x, x, minus 2 minus 6. So this gives me x equals 2, which would lead to y equals 1, which was the given point. This gives me x equals 6, which means that y is, so we know the relationship, right? Y is negative x plus 3. So negative 6 plus 3 is negative 3. Therefore, 6 negative 3 is the other point. The other point on the curve where slope equals the slope at 2, 1. All right, I think that's it. So let's look at our logic. The slope was negative 1/3. Set that up, get a relationship between x and y. So this should be the relationship. And we confirmed that it worked at 2, 1, which was the given point. So that was good. Took the relationship and we replaced every y that we saw here in, whoop, you're not a highlighter. Every y that we saw here with the relationship. This is the original curve. Do some algebra stuff, get 6 negative 3. So I'm going to check it on the calculator, or do it on the calculator. I don't really actually know if it's right or not. And then just to show you that you can, like obviously 1973 calculator wasn't really quite the option that it is now, but that's okay. Doesn't mean that you shouldn't like try to apply new technologies to old problems. So I'm going to use implicit differentiation, which is menu 4 up, up. Press menu 4 up, up, and I think you will get that. X plus x times y, not optional. 2y squared equals 6 comma x comma y. So this will give us our first derivative. Let's do such that x equals 2 and y equals 1. We get this. It's actually easier, by the way, when you're doing it by hand, like on the handheld, to do such that x equals 2 and then do such that y equals 1. I think it's faster than typing and, but you know, it's up to you. So I think we got the correct tangent line. And then I want to solve this equals this. Can I say like and? I don't know if this will work. I've never actually tried to do this as a system before. I don't know why it wouldn't. And this is true for x and y. And let's see. So we get 2, 1, and we get 6, -3, which is exactly what we had. So I think we did it. All right, I'm gonna go back and just show you, I don't know, show you the work one more time. Call it quits on this one, do one FRQ per video, right? I mean, that's like a reasonable amount, I think. I don't know. So I never really use the old program that I used to use. Maybe I should go back to that. I think it's like higher definition. I don't know. Anyway, I hope you found this helpful, and good luck.